Hello everyone, welcome back to our YouTube channel GurMantra Shiksha Ka Granth. I am your educator Nidhi Dua and I warmly welcomes you at this platform. So guys, in today's lecture we are going to discuss about the ionic equilibrium. In ionic equilibrium we are going to cover the topic about pH. Okay, so let's begin our today's topic, that is pH scale. So basically pH scale was given by a scientist named Sorensen. And if you talk about pH, what is pH, or you can say what is pH scale, then pH scale is a measuring scale that is used to measure the strength of acid and base and its value. Okay, which means pH is the term that is used to measure the acidity and basicity of a substance. Okay, and to calculate the value of pH, we have a simple general formula that is equals to minus log of H plus ions concentration, or you can say log 1 by H plus ions concentration. Now, for example, if you have given the H plus ions concentration equals to 10 to the power minus 3 and you have to calculate the value of pH, then you can simply calculate the value of pH by putting the value of H plus ions concentration in the general formula to calculate pH, that is equals to minus log concentration of H plus ions. Then you have put it the value minus log into 10 to the power minus 3. We have studied a general formula that was, if you have given minus log x to the power y, then the value will becomes y log x, which means here the power is minus 3, then this is the value of y, that means this minus 3 will shifted in front of log, which makes it minus 3 into minus log, which makes it as plus 3 log 10, and the value for log 10 is 1, that's why pH will be equals to 3 into 1, that is 3. Okay, so we have a general conclusion, that is if pH is given you x and you have to calculate the value of H plus ions concentration, you can simply write 10 to the power minus x is the concentration for H plus ions. Or vice versa, if you have given the concentration of H plus ions as 10 to the power minus x, then the pH will be the power of this 10 to the power this 10, then pH will be x. Similarly, if you have given the pOH, you can calculate the value of pOH, the basicity, that will be equals to minus log OH minus ions concentration. Okay. Next we have the types of pH. You know it very well, we have different kinds of salts. These salts can be made from strong acid, strong base, a lot of mixtures. Okay, so we have types of pH on the basis of these mixtures. First of all, we have pH of strong acid and strong base. If you talk about the pH of strong acid and strong base, this will be equals to the concentration. And if you want to calculate the pH of weak acid and weak base, then it will be equals to C alpha and C alpha. To calculate the pH value, that will be equals to C alpha, and to calculate the value of pOH, this will also be equals to C alpha. Now we have 4 different kinds of salts, and these different kinds of salt can be made from different kinds of mixtures, and these different kind of mixtures has different value of their pH. First of all, we have a mixture of strong acid and strong base. The salt that can be made from strong acid and strong base has the pH equals to 7. Second mixture is strong acid and weak base. This type of mixture will have the pH less than 7. Means if we have a solution that has strong acid and weak base, then this solution will be acidic, highly acidic. Okay. Third mixture is weak acid and strong base. If we have weak acid in the solution and strong base, then the salt type will be the basic, which means pH has the value greater than 7. And if you have a mixture that has weak acid and weak base, then the salt will be then the pH of the salt will be equals to 7, or you can say almost 7. Okay. Next we have pH mixtures of acid and base. Number 1 is for acids. To calculate the pH for acids, we have different kinds of mixtures, and we are going to prepare a single solution by different acids, and different acids has different concentration and volume. If you want to calculate the pH of that particular complete solution, we have the general formula N1V1 plus N2V2 plus N3V3, that will be equals to the NV. Now what are N and V? N is the normality of final solution, that is equals to the concentration of H plus ions, and V is the volume of final solution, that will be equals to V1 plus V2 plus V3 of different acids present in the particular solution. Similarly for base, we have the value N1V1 plus N2V2 and so on is equals to NV. Here V is the similar volume of final solution, that has the value V1 plus V2 plus V3 and so on, and normality of final solution will be equals to the concentration of OH minus ions, since this is for basic solution. Okay. Next we have pH mixtures of acids and base. If you have a solution having acid and base, then for acid you have calculated the final value NV acid. For base this is equals to NV base, and if in a particular solution having acid and base the content of acid is greater than the base, then the solution will act as a acidic solution. Okay, and to calculate the value of NV you can calculate it by subtracting the NV acid by NV base, and the concentration of normality will be equals to H plus ions. Similarly, in case of basic solution, if the concentration of basic solution is more in the solution and acidic has the less concentration, then the solution will be highly basic, and to calculate the value of NV you can calculate it by NV base minus NV acid, and the concentration of OH minus ions will be equals to the normality. Okay. Next we have the ionization of weak acid and weak base. For ionization of weak acid and weak base, we will see the 3 different equations. Okay. So firstly we are going to talk about for mono-basic weak acid. Okay. To calculate the first of all ionization constant for weak acid, this ionization constant for weak acid can be represented by Ka. We have a reactant Ha that is dissociated into H plus ions and A minus ions. Initially concentration of reactant is C and product has 0, 0. At equilibrium condition this becomes C minus C alpha and product becomes C alpha and C alpha, as you have seen in the previous classes. Next, if degree of ionization is alpha, then you can calculate the value of Ka by applying the law of mass action. Law of mass action says you have to simply write down the active masses of product divided by active masses of reactant. So simply you have written this Ka is equals to C alpha into C alpha divided by C minus C alpha. When you calculate this equation, you will get the value of Ka is equals to C alpha square divided by 1 minus alpha. If the value of alpha, if the degree of ionization is less than, very less than 1, then you can simply say 1 minus alpha is nearly equals to 1, which means Ka will becomes equals to C alpha square, and K is the ionization constant for weak acid. Okay. Second we have, if you want to calculate the concentration of H plus ions in case of monobasic weak acid, then you can calculate it by a simple general formula, that is H plus ions has equals to Ka into C. From where this equation comes, you know it very well. H plus ions concentration has Cl equals to C alpha, K is equals to C alpha square, or you can say alpha is equals to under root Ka by C. From this equation number 1 and equation number 2, you can simply calculate the value of H plus ions, and this is equals to under root Ka into C. Third, you have to calculate the value of pH for weak acids. That pH is equals to minus log H plus ion concentration. So you have calculated the value of H plus ions, that is equals to under root Ka into C. You have simply put it the value of H plus ions into this general equation. After solving this general equation, you can simply say pH is equals to half pKa minus half log C. Log Ka minus half log Ka is equals to half pKa. Okay. Now, if we talk about the B part for monoacidic weak basic solution, if you want to calculate all these three things for weak basic solution, then first of all we have ionization constant. In case of weak basic solution, ionization constant is represented by Kb. Okay, simply we have a reactant BOH. It is dissociated into the product B plus and OH minus ions. Initial concentration, let's take C, and equilibrium condition, that will be equals to C minus C alpha. For product, this will be equals to C alpha and C alpha. After implying the law of mass action, you can simply calculate the value of Kb, that is equals to C alpha square. Okay, why? 1 minus alpha can be nearly equals to 1 if the value of alpha is very less than 1. Okay, and Kb is the ionization constant for weak base. Next, you have the concentration of OH minus ions. If you want to calculate the OH minus ion concentration, you can simply learn the following formula, that is K under root Kb into C. What is Kb? Kb is the ionization constant for weak basic solution and C is the concentration given to you. Third, you can calculate the value of POH, that is equals to minus log OH minus ion concentration. You have calculated the value of OH minus ions concentration, that is equals to under root Kb into C. By simply putting the value of OH minus ions concentration in the general formula to calculate the value of POH, you will get the value for POH is equals to half pKb minus half log C. Okay. Okay, so from all these points, you can conclude that for weak acid, value of Ka is equals to C alpha square, while for weak base, this is equals to Kb is equals to C alpha square. If you want to calculate the H plus ions concentration in weak acid, this will be equals to C alpha is equals to under root Ka into C. And similarly, to calculate the value of OH minus ion concentration, this will be equals to C alpha, that is equals to under root Kb into C. In case of pH for weak acid, this will be equals to minus log H plus ions concentration. For weak base, the value of POH will be equals to minus log OH minus ions concentration. Similarly, pH will be equals to half pKa minus half log C in case of weak acid, and in case of weak base, POH will be equals to half pKb minus half log C. Next, we have the factors affecting the value of degree of ionization. Okay, so number one factor is temperature. When you increases the temperature, the ionization of a particular solution also increases, which means alpha increases. Second, we have the dilution. Alpha is directly proportional to the under root V, which we can say that on dilution the value of alpha also increases. Third, you have the nature of electrolyte. If you have a strong electrolyte, then there will be a complete dissociation, that is equals to 100%. And if you have the weak electrolyte, then the dissociation will be less than the 100%. Okay, so these were the some factors affecting the value of degree of ionization. Next, you have the two questions which you have to solve. Number one question is, find out the POH if 10 to the power minus 3 molar concentration solution of NH4OH is given if the value of Kb is 10 to the power minus 5. So guys, you have 30 seconds to solve this question. Please do this question quickly. Okay guys, let's see the solution for this question. You have to calculate the value of pOH and you have given the concentration and the value for Kb. So first of all, to calculate the value of pOH, you will require the concentration of OH minus ions. So first of all, we need to calculate the concentration of OH minus ions. And we know it very well, to calculate the OH minus ions concentration, the general formula is under root Kb into C. And value of Kb and C is given to you in the question. Simply you have to put the values in this general equation. When you put up the values, you will get the concentration of OH minus ions as 10 to the power minus 4. And now to calculate the value of pOH, you have to put this concentration of OH minus ions in this general formula, that is minus log OH minus ions concentration. When you put up the value, you will get the answer as pOH is equals to 4. How? Minus log 10 to the power minus 4. This minus 4, this power will come in front of log, then this will become 4 log 10, and the value for log 10 is equals to 1, which means pOH concentration will be equals to 4. Next you have, for 10 molar concentration CH3COOH solution, if Ka is equals to 10 to the power minus 5, then find out. You have to find the three parts. Number 1 alpha, second H plus ions concentration, and third pH. Guys, you have 1 minute time to solve this question. Okay guys, let's see the solution for this question. You have given the value for concentration and the value of Ka. Okay, first of all you need to calculate the value of alpha. So you know it very well, Ka is equals to C alpha square. You have put it the value for Ka, that is 10 to the power minus 5. Concentration is given, that is 10, and now simply you can calculate the value for alpha, that is equals to 10 to the power minus 3. Now to calculate the value of H plus ions concentration, that is equals to C alpha. So C concentration is 10, alpha you have calculated 10 to the power minus 3. When you solve this, you will get the concentration for H plus ions as 10 to the power minus 2. Next part is to calculate the value of pH. pH has the general formula, that is minus log H plus ions concentration. After putting the value for H plus ions concentration, you will get the pH as 2. Okay, so guys, this was all about today's lecture. Now in case if you are new here at our YouTube channel, you can like, share and subscribe. You can also join our Telegram channel GurMantra, and if you have any query, you can mail us or contact us. Complete information is given to you on your screens. Now a very important announcement, if you are preparing for CSIR-UGC NET, you can follow Neha Taneja ma'am on Unacademy platform. On Unacademy platform, you will get daily life classes, structural courses, live tests and quizzes, and with one subscription, you will get unlimited access. If you are interested, you can go through with this detailed paid classes. You can use referral code NEHA after taking these detailed paid classes. And while using this referral code, you will get 10% discount on total fee. Thank you very much guys. I hope now you all are cleared about the today's topic. Okay, that was based on pH.